Hello students. In this video we will learn about solving nonlinear inequalities. Before we learn the method of solving nonlinear inequalities, we need to know what are nonlinear inequalities. They are not linear. In the sense, in linear inequalities, we had just constants and powers of the variables to be 1. Here, these inequalities, that is nonlinear inequalities, they involve squares and other powers of the variables. Before we get into the details of how to solve these kind of inequalities, we will recall certain operations that we do where signs are very important. Like if you have a minus sign, that is if you have a negative sign and it is multiplied even number of times, so we get positive sign. Correct? And if the same sign, the negative sign, if it is multiplied odd number of times, so we get negative sign. The same thing applies to division as well. So if you have division, if the numerator and the denominator, or if you have negative sign in while dividing even number of times, that may be like 2 times, 4 times, so you will get a positive sign. So it is not just multiplication, it applies to division also. And again here, multiplied or divided odd number of times, we will get negative sign. So this is very important. You will see why and how. So let's get into the solving nonlinear inequalities. Say for example, I have x square minus 5x less than or equal to negative 6. So I will operate plus 6 on both the sides to eliminate my RHS. So I'll be getting x square minus 5x plus 6 less than or equal to 0. Now I can factorize the LHS. So that would be x square minus 6 is nothing but 2 and 3. So where upon adding them, we will get 5, but we should get negative 5. So I will get 2x minus 3x plus 6 less than or equal to 0. So taking x common out of first two terms, we get x minus 2. And taking negative 3 common out of the last two terms, we get negative 3 times x minus 2 is less than or equal to 0. So now x minus 2 is common in first and second term, and we are left with x minus 3, that is less than or equal to 0. So you can see, like I'm not telling you the actual process that goes into. So vaguely, like with trial and error method, we can see that the given inequality can be split into three ways. So that is x minus 2 times x minus 3 is equal to 0. This implies either of the term has to be 0. So x minus 2 is equal to 0 or x minus 3 is equal to 0, right? So that implies x equals 2 or x equals 3. And the other part of the inequality is x minus 2 times x minus 3 is less than 0. Okay, it is less than 0. So now what can we say? That means either this term has to be negative or this term has to be negative. Or if both are negative, if you multiply negative sign even number of times, what do we get? We get a positive signs that we just recalled now. So that either this has to be negative or this has to be negative. So we have 2 and 3. That means you can have less than 3 implies less than 2 also. But can we take less than 3 and less than 2 together? No, because that would give us a positive sign. So we are eliminating less than 2. We should just take less than 3 as well as 2 and 3, because there is an equality sign in the inequalities. Therefore, x will take values from closed interval 2 comma 3. So this went on a very vague method, like it is not possible to discuss the type of solutions, and there is a step by step method. Step by step method that you can follow to solve nonlinear inequalities. So all the steps goes like this. The same inequality, we will consider the same inequality, which is that x square minus 5x is less than or equal to negative 6. Okay, so first step 1, move all terms on one side. Either you decide you want to move them towards the left side or you want to move them towards the right side. Move on one side in the sense you are operating some negative or positive. You are cancelling out one side completely. So you are operating all the opposite terms with opposite signs and inverses of each term on one side. So for example, here inverse of negative 6 is plus 6, which gives us 0. So moving minus 6 towards the other side means operating plus 6 on both the sides. Okay, so step 1 is move all terms on one side. It is your wish, you move anything towards any side. So I am moving RHS to LHS. So that would be x square minus 5x plus 6 is less than or equal to 0. You should understand the process behind moving. It is nothing but operating plus 6 on both the sides and cancelling out the negative 6 that was on your right hand side. So step 2, factorize LHS or RHS, whichever side is your expression. In this method, I have my expression on my left hand side. So therefore, factorize LHS. Factorize LHS. Yeah, we did that before. So we got like x minus 2 times x minus 3 less than or equal to 0 after factorization. Okay, next step 3, find intervals. So you have the factor, solve all the factors and find for 0, like equate the factors for 0 and find the values that x can take. So in this case, x can take 2 and x can take 3. It is not like I am considering the equals 0 here. It will be done even if there is a strict less than sign or strict greater than sign. You have to equate the factors to 0 and find out what values x can take. So how to convert this into intervals? Take the real line and plot this on the real line. So now you can see this would be negative infinity and this would be positive infinity. Now you can see the real line has been divided into 3 parts. That is negative infinity to 2, 2 to 3, 3 to infinity. So consider only open intervals of this format, that is negative infinity to 2, to open interval 2 comma 3 and 3 comma infinity. This is how you divide the given inequality into intervals. So this is our step 3. Okay, now you can observe that the sign changes exactly at 2 and 3. So the sign, that is the less than or equal to sign, changes at 2 and 3. In between this, it will be one sign. It will be equal to 0 at 2. So it changed, less than changed to 2, equals at 2. And then it changes again within the interval and changes to equal to 0 at 3. So at these two positions, we have the sign change. Therefore, we are not including them in the intervals. Okay, within the intervals, the sign is maintained for all the values. Okay, our step 4 is make a table or diagram. I prefer diagram. Okay, you can make a table also. You will see like how I split things, so that should be put into cells. That's it. So there is nothing different in writing a diagram or a table. So for that you have to establish the real line and divide it into parts as we did in the step 3. Okay, so this was negative infinity and infinity, and we were not considering 2 and 3. So we had intervals negative infinity to 2, 2 comma 3, and open interval 3 comma infinity. So now we will take trial values inside each of the intervals, take suitable values which you find easy, and apply it to the factors and check what sign do we get. For example, we will now sine of x minus 1, sine of, x minus 2, right? Yeah, x minus 2, and sine of x minus 3, and sine of product x minus 2 times x minus 3. Okay, so trial values, I will tell you how to take the trial values, and signs, you will write down the signs. Okay, for the first trial value, I will take in the interval negative infinity comma 2. So I have 0 inside negative infinity comma 2. So I will take x equal to 0 here. Okay, within the interval negative infinity comma 2. So what would be the sign? 0 minus 2 is negative, 0 minus 3 is negative, but the product, so product is giving a positive. So this is opposite to less than or equal to. It is neither equal to 0 nor less than, it is not less than 0 because you are getting a positive sign. So this interval is neglected. You should not consider that interval. Moving on to the next interval. Take a trial number between 2 and 3. So I will take 2.5. So x equals 2.5. So 2.5 minus 2 would be 0.5. So that is positive. 2.5 minus 3 is negative 0.5. That is negative. Positive times negative product will give you negative. So this interval is working for us. So we have negative sign, that is less than 0. It is satisfying the given inequality. So we can consider this interval. So third trial value between 3 and infinity, I will consider 4. So when x equals 4, what happens to x minus 2? Is it positive or negative? It is positive. X minus 3 will be positive. And the product of x minus 2 and x minus 3 will definitely be positive because positive times positive is positive. Again, this interval is also ruled out. So what are we left with is 2 comma 3. So we are sure that x will be taking values from 2 and 3. So can x take values exactly 2 and exactly 3? Yes, because we have less than or equal to 0. That is x minus 2 times x minus 3 has an equal sign also. So it can take less than or equal to 0 and including all the values in between 2 and 3. Therefore, the solution of x minus 2 times x minus 3 less than or equal to 0, that is, what was that? X square minus 5x minus 6. Am I right? Sorry, plus 6. Yeah. Plus 6 less than or equal to 0 is, what are all the permissible values of x? X such that 2 is less than or equal to x less than or equal to 3. That is closed interval 2 comma 3 if you are supposed to express it as an interval. And if you want to shade it in a real line, so that would be 0, 1, 2, 3. So shade all the numbers in between 2 and 3 including 2 and 3. So this is how you find the solutions by steps. I will repeat it, or maybe I can do another problem. Yeah, I will do another problem. It would be like recalling the steps again and doing it. So this is problem number 44 in your book. That is, x square is less than x plus 2. So here you have strictly less than. So maybe you may get an open interval or you may get a closed interval, and don't judge or skip any process. Like at the last process, after you find out in which interval is satisfying the given rule, you need to check the endpoints as well. You will understand an example when we do like solving quotients of inequalities. Then you have certain possibility of the sign being strictly less than or strictly greater than, but you get a closed interval. You have such cases. So you should not skip the method. You should check even whether the endpoints also satisfy the inequality or not. Okay, coming to this thing, what was our step 1? It was to bring all the terms towards one side. Again here I will bring all the right hand side terms to the left hand side. That would be nothing but operating right hand side with negative x, negative 2. So that would be negative x, negative 2 less than 0. So now step 2 would be to factorize. So how do you factorize? X square, 2 has 2 and 1 because it's a prime number as factors, and you need negative 1 out of that. So negative 2x plus x minus 2 is how you split the middle term. So this implies x of x minus 2 plus 1 of x minus 2 less than 0. So that implies x minus 2 times x plus 1 is less than 0. Okay, step 3, equate the factors to 0. X minus 2 equals 0, x plus 1 equals 0, and find out what are the values. So that would be x is 2 and x is negative 1. Plot that on the real line and find out the intervals. So that would be 0, negative 1 and 2. Correct? So 1. Yeah, I don't want this 1 and 0 in between, so that I will get confused with number of intervals. So this is how. Okay. Yeah. So now in this case we have 3 paths. That is negative infinity comma negative 1, negative 1 comma 2 open interval, and 2 comma infinity as our intervals. So step 4 is to draw a table or a diagram for the same thing. take trial values in between each interval and check the sign. Here sign of x plus 1, sign of x minus 2, and sign of x plus 1 times x minus 2. So what is the trial value in between negative infinity comma negative 1? I'll consider negative 2. So if I take negative 2, negative 2 plus 1 would give me negative 1. So that is negative. Negative 2 minus 2 would be negative 4. That is negative again. So negative times negative is positive. Can we have positive? No, because our inequality says less than something. So this would be, we are going to rule out this interval. So next, consider the trial value 0 here. So 0 plus 1 is positive. 0 minus 1 minus 2 is negative. Positive times negative will give us negative. So this is a correct interval. We can consider this interval. Next, we need to check a trial value between 2 and infinity. So I will consider x equals 3. 3 plus 1 is positive. 3 minus 2 is positive. So positive times positive is positive. So again, this part of the interval is ruled out. What we are left with is negative 1 comma 2. Now we have to check the end points as well. So when x equals negative 1, x plus 1 will be 0. So this doesn't satisfy the inequality. So we need not consider negative 1. When x equals 2, x minus 2 is 0. So when x minus 2 is 0, we need not consider product will also be 0. So that whole inequality becomes equal to 0. So we need not consider this value as well, this end point as well. So what we are left with is open interval 1 comma 2. So this is the solution. All values come in of x are in between negative 1 and 2. To write this in set builder method, solution of the given inequality is set of all x such that negative 1 is strictly less than x, strictly less than 2. This was a perfect recall, like we solved the problem as well as recalled the steps to follow. This applies to any kind of method that you do. Here is your quiz. We are still in section 1.8, so it is 1.8.2. Solve 5x square plus 3x greater than or equal to 3x square plus 2. You should use the steps to solve it. X plus 4 times x minus 5 greater than or equal to 0. 3. 2 minus 3x times x is less than or equal to 0. So these two are really easy because you don't have to do first and second step in both the cases. But here you have to do first and second step. But you can mention that there is no necessity of first and second step in second problem and third problem and do further steps properly. So what happens if there are repeated factors? Like for in the case, we will learn in now solving non-linear inequalities with repeated factors. Nothing changes. You perform all the operations, all the steps as it is. Even the checking of the sign should be performed, but for the repeated factors. So we will see that. I have considered number 54 of your exercise. if I have x plus 3 the whole square times x plus 1 greater than 0, so this is already factorized as well as all terms are on one side. So you can skip first two steps. The next step was third step. Step 3 was to equate all the factors to 0. So it is okay if you consider without powers. So if x plus 3 is 0 and x plus 1 is 0, x value would be negative 3 and x value would be negative 1. Okay, to divide it into intervals, so negative infinity to infinity, negative 3, negative 1. So again here you have the intervals to be open interval negative infinity comma negative 3 and negative 3 comma negative 1 and open interval negative 1 comma open interval infinity. So now to draw a table, check the signs with trial values in each interval. So our intervals are these. Okay, but because you have repeated values, you will check the sign for the repeated factor only. Sign of x plus 3 the whole square and sign of x plus 1 and sign of their product, sign of x plus 3 times x plus 1. So between negative infinity comma negative 3, I will consider negative 4 as my trial value. So negative 4 plus 3 would give me negative 1, but squaring them will give me a positive sign. Okay, and negative 4 plus 1 will give me negative 3. So this will give me a negative sign. So my final answer would be a negative sign. So, but you cannot consider that because we have a greater than or equal to symbol here. So this interval is ruled off. Next, considering the trial value in between negative 3 and negative 1, I can consider negative 2, right? Yes, I can consider negative 2. So in this case, negative 2 plus 3, that is 3 minus 2 is 1. 1 square is positive. Good. So negative 2 plus 1 is negative 1. So it is negative. Again, you are getting a negative value, whereas we should get greater than sign. That means a positive value. So even this interval is ruled off. So next, in between minus 1 and infinity, I will consider 0. Okay. So if I consider 0, 0 plus 3 would be 3. 3 square is 9, that is positive. 0 plus 1 is 1, so that is positive. Positive times positive is positive. So this is greater than 0. I can be pretty sure that I have this interval that is satisfying the inequality. Now it's time to check my endpoints. So that would be x equals negative 1. If you substitute negative 1 in the this thing, sorry, I have written this to be only x plus 3. It is x plus 3 the whole square. Okay, if you substitute negative 1 plus 3 would be 2. 2 square is positive and negative 1 plus 1 is 0. So you will get the product to be equal to 0. That is never possible because you have a strict sign here which is greater than 0. So you rule out the endpoints. So our solution is the interval minus 1 comma infinity, which written in a set builder notation would be minus 1 less than, strictly less than x less than infinity. So this is our solution for the given inequality. Now we will see how to solve quotients if we have rational expressions as inequalities. So how to solve them? So solving non-linear inequalities involving a quotient, fractional or quotient. It can be a fractional expression and or a rational expression. So like this, this I do not remember the number of the, this is an exercise problem again, so I will number it as 1. X minus 4 divided by 2x plus 1 less than 5. So here our step 1 applies because there are terms on both the sides of the inequality. Therefore, I should bring all the terms towards one side. So step 1, that would be x minus 4 divided by 2x plus 1 minus 5 less than 0. Step 2 is you simplify this and factorize. So this is, I should take an LCM. X minus 4 will be retained as it is. Negative 5 times 2x plus 1, because that is the thing that you should multiply with 1 to get back your LCM. Okay, so simplifying it further, we get x minus 4 minus 10x minus 5 divided by 2x plus 1. That is distributing negative 5 over 2x plus 1. So that would give us minus 9x minus 9 less than 0, divided by 2x plus 1. So you can see the numerator negative 9 times x minus 1, x plus 1 divided by 2x plus 1 less than 0 is our final factorized form. You may be tempted to multiply 2x plus 1 on both the sides and cancel out the denominator. But you do not know whether 2x plus 1 is negative or positive to apply this rule. CA, you remember A less than or equal to B. When C is greater than 0, you can retain the inequality. If C is less than 0, you have to reverse the inequality. So we do not know what is the sign of this so that we can retain or reverse the inequality. So that is why we do not undergo that procedure of multiplying 2x plus 1 and cancelling out. That can be done only with the real numbers, not with expressions. So now what we do, step 3 would be to equate all the factors to 0 and find out the points which satisfy the equation. So x plus 1 has to be 0 means x has to be negative 1. 2x plus 1 has to be 0 implies 2x should be negative 1. That implies x should be negative 1 divided by 2. That is negative 0.5 in decimal format. So if you have to plot this on a real line, it would be negative 0.5 is greater than negative 1. So this is how your intervals are. So what are the intervals? Negative in open interval negative infinity comma open interval 1, open interval 1 comma open interval 0.5, open interval 0.5 comma infinity. Okay, good. So now step 4 is to draw a table or a diagram to find out the signs which satisfy, to find out which intervals has all the values satisfying the given inequality. Step 4, I will just write down the inequality to be sure. Negative 9 x plus 1 divided by 2x plus 1. So this is where division of even number of negative signs or odd number of negative signs comes into picture, that we discussed at the beginning of the video. Okay, considering trial values between these intervals sine of minus 9x plus 1 sine of 2x plus 1 and sine of division of them. So 9x plus 1 divided by 2x plus 1. So when I consider this interval, I would like to consider the trial value x equals negative 2. So what happens? Negative 2 plus 1 would be negative 1. Negative 1 times negative 9 is positive. I should be getting this less than or less than 0. Yeah, I'm right. Okay. And negative 2 times 2 would be negative 4 plus 1 would be negative. Okay. So numerator is positive, denominator is negative. So you will get negative as an answer. Correct? So this interval can be considered because we have less than 0 sign. Next one. In between negative 1 and negative 0.5, I consider negative 0.6. Okay. Negative 0.6 plus 1 would give me 0.4. Positive times negative would give me negative. And 2 times negative 0.6 is 1.2 or something. Yeah, 1.2 plus 1 would give me positive. Yeah. So hold on. Yeah, 2 times yeah, so that would give me positive. So then the final dividing the signs, you get negative value. So in the third interval, I will take a trial value to be 0 because that is easy. Yeah, 0 plus 1 is 1 in x plus 1 and times negative 9 would be negative. 2 times 0 is 0 and plus 1 is 1, that would be positive. I'm sorry, I was like trying to find out how to highlight what I'm speaking about. Where, okay, I was looking for a pointer. Yeah, so positive. So negative and positive will give us negative upon division. So again, this particular interval is ruled out. So we are just left with the interval, this one. So that would be minus 1 comma minus 0.5. So now check the endpoints. This is very important. You should check the endpoints. There are all the possibilities of, like, especially when you are dividing, there are all the possibilities of you getting a value that may satisfy the inequality at the endpoints, especially when you are dealing with quotients. So do not skip any step, any sub steps as well, so that your answers has to be perfect. So when x is negative 1, you have 9 of negative 1 plus 1 is 0. So your inequality cannot be equal to 0. This is ruled out. So 2x plus 1 would be 2 of negative 1 plus 1 would be negative 2 plus 1 is negative 1. Yeah. So yeah, it doesn't matter what the denominator is, because once the numerator is 0, the fraction will turn out to be 0. So both the negative 1 is ruled out. Next, if we consider x equals 0.5, so we have minus 9 of 1 minus 0.5. So that would be negative. And 2 times 0.5 plus 1. So 2 times 0.5 plus 1 is, what do you get? 2 times 0.5 is 1. Negative 1 plus 1, that is 0. So this is not at all defined. So even this endpoint is not considered. So x is taking the values in between open interval negative 1 comma negative 0.5. Therefore, writing it in the set builder form, solution is x such that negative 1 less than x less than minus 0.5. So we will solve quiz now. Quiz 1.8.3. Solve. First one, 1 plus x divided by 1 minus x less than or equal to 1. 2x plus 6 divided by x minus 2 is less than 0. 3. 4x square times x square minus 9 less than or equal to 0. 4. X square greater than or equal to 9. Actually, the level of difficulty decreases as you go further. Yeah, the last problem is very easy, and third is easier than 2. It's like that. Yeah, solve this, and we will learn about absolute inequalities in the next video. See you soon. Thank you.